Hello everyone, hope you all are having a great day, hope you all are doing well. So today in this video we'll be discussing the Leetcode's daily coding problem, and we'll be discussing about the approach, and also I'll be coding that in C++. And even if you are coding in other languages like Python or Java, then also this approach will going to be very helpful to you. Okay, so without further ado, let's jump right into the problem. Okay, so this is the problem that we have. Okay, it's saying minimum bit flips to convert number. So what the problem is, a bit flip of a number x is choosing a bit in the binary representation of x and flipping it to either 0 or 1 or 1 to 0. So basically if a number is 0, we are going to make it 1, or we are going to flip it to 1, and if it is 1, then we are going to flip it to 0. Okay, so for example, for x equal to 7, the binary representation is 111, and we may choose any bit including any leading zeros not shown. So he's also talking about the zeros on the left side. Okay, and flip it. We can flip the first bit from the right to get 110, flip the second bit from the right to get 101. Okay, so this is like he's saying we have like 111. So if I flip the first bit, then what is going to happen? If I flip the first bit, then it's going to be 110, right? First bit from the right. If I flip the second bit from the right, it is going to be 101. Flip the fifth bit from the right, a leading zero, you'll get 10111. So now it's saying that you have this, which is nothing but this, and now what you do is you flip the fifth bit from the right, which is nothing but this bit. So he's simply asking us to do this 10111. Now this is the number, okay, etc. Given the two integers start and goal, return the minimum number of bit flips to convert start to goal. So basically we need to convert this start to goal by flipping the bits. That's what this whole question is all about. So in the question we are given start equal to 10 and goal equal to 7. Okay, yeah, I think I'm visible now. Just quickly understand the approach. So what is 7? 7 is nothing but 1 1 1. What is 10? As a 7's binary representation is 1 1 1. Now there is, if you are a total beginner who doesn't even know binary representation, then you should check out the videos where they explain how to do decimal to binary or binary to decimal. But here I am assuming then that you know these things. Okay, so the binary representation of 7 is 1 1 1, and what is 10? It is 8 plus 2, right? Right, this is the binary representation of 10. Now we need to find the number of bit flips that will be required to make this number, this number. Okay, so what are the bit flips? So what I can do here, I can change this 0 to 1. Okay, this will remain as it is because 1 1 is already there. Then what I have to do is, in this case I need to change this 0 to 1, and in this case I need to change this 1 to 0. So how many? What is the count? 3, right? Fine. Now let's discuss about the approach on how we'll be doing it. So we have 1 0 1 0, we have 1 1 1. Okay, there is an operator which is known as XOR. Okay, now what is XOR? XOR is, if you have same bits, okay, the table looks like, the table of XOR looks something like this. If you have 0 0, then it's going to return 0. If you have 1 0, it is going to return as 1. If you have 0 1, it is going to return as 1. If you have 1 1, It is going to return as 0. So basically for same bits you are going to get 0, and for different bits you are going to get 1. Okay, this is the idea. So now think of it. If I XOR this whole thing, if I XOR this whole thing, this thing that you are seeing right now, if I just XOR it, what happens? 1 0 is what? 1 0 is what? 1 0, oh sorry, 1 0 is what? 1. Okay, 1 1 is what? 0. 0 1 is what? 1. Then 1, you can say that it's a 0 here. So 1 0 is what? 1. So this is what the number you get after doing the XOR. Okay. Now since we have done the XOR, how we can do XOR? We can say that okay, int num is equals to start XOR goal. Okay, this is what we have done till now. Fairly simple step. And what we got here is num we got as 1 1 0 1. Now what we can do is we have this number 1 1 0 1. We can simply AND it with 1. Okay, think about it. See, here we found the XOR. In XOR operations, the bits that were same, they didn't change. Okay, because anyhow, okay, they did change. Okay, so basically if we have, let's say, 0 0, it's going to remain as 0. If we have 1 1, it's going to remain as 0. If we have 0 1, then it's going to show us 1. If it's 1 0, it's going to show us 1. So basically what you can understand here is, what you can understand, see, 1 0 1 0, these bits are different. 1 1 0 is different. Okay, therefore I am having here 1 1 1 is same, 1 1 is same, 0. This 0 simply means that I don't have to flip this bit. Okay, and this 1 shows that both the bits are different, so I need to flip it. Then this 0 1 shows that both the bits are different, so I need to flip it. Okay, then this 1 0 shows that both the bits are different, therefore I need to flip it. That's how, once I have this, if I AND it with 1, what happens is 1 1. What is the answer of 1 1? Answer of 1 1 is 1, right? What is the answer of 1 1? It is 1, right? And this shows me that I need to flip this bit. Okay, so initially the count equal to 0. Now with 1 1, the count became 1. Okay, then I need to right shift this entire expression. So I'll say 1 1 0, and then I'll again AND it with 1. Okay, now what happens? We have 0. Okay, this is simply, these are zeros. Okay, so you can say, so let's just remove them. So what is 1 0? 1 0 is nothing but 0. This tells me that these, okay, this number tells me that both these bits were same. That is why that is why the result was 0. Okay, now ANDing it with 1 just tells me that the result 0 tells me that we don't have to flip these bits. Okay, they were already same, we don't have to flip them. So the count remains 1, count equal to 1. Okay, then we are going to again right shift it. So what is the right shift? 1 1 1, and what is the result of it is 1. Therefore count became 2, right? Now we need to again right shift this expression. So then again AND it with 1. We got 1. So count equal to 3. That is how we came up with the answer. Okay, I hope that's clear to you. I tried to explain it in the best possible manner. If you still have doubts, please let me know in the comment section. But before that, let's quickly jump into the code. In code also, I'll try to explain it to you. Okay, so maybe even if you have any doubt by now, I hope it gets cleared by the end of the video. Okay, so let's quickly jump into the code and just complete it. Okay, now just look into the problem. What we have is what I told you. Let's first make a number which is nothing but start XOR goal. Okay, now what we need to do is, while we have this number, first let's define a variable int count equal to 0, and then while we have this number we need to run a loop. Okay, now what we have to say is count plus is equals to, we need to find the XOR of sorry, not XOR, the AND of this number and 1. So if we have a 1 in the ones position, then we can say that we need to flip this bit. If we have a 0, then we need to say that we don't have to flip this bit. Very simple. So what is, it's not cout, it's count. So simply we are increasing, so we are finding the count and then we are right shifting this num by 1. So we can say num is equals to num right shift by 1, simple, and then we are going to return count. What? Okay, let's try to run this. Any issue? No. Submit it. Okay, it was a fairly simple problem, it got accepted. Now let's quickly talk about the time complexity. So time complexity is simply constant. I'll tell you why. First, in the question it's given that the maximum bits, max bits, is nothing but 30. Okay, this is given in the question. And what is time complexity? See, think about it. When we had 10, what is 10? 1010. What is 7? 0111. Which is the maximum bit? Maximum bit is this one, right? This is the maximum bit. So anyhow, even let's say, even if we have a 30 bit of number, any number you can imagine, which is having, how many bits it has? It has 4 bits, right? 4 bits. I can say, let's say if there is a 30 bit number, okay, anyhow you XOR it, you can XOR it with, let's say, another 30 bit number. So it cannot be greater than 30, so either it's going to be 30 or less than 30. Anyhow, the number of bits that you will get in the answer is going to be 30 bits, right? You are finding the XOR, so you will get 30 bits. Once you have 30 bits, so you can say that the maximum bits is 30 bits. What if it would have only 10 bits? Then the preceding zeros would have been like this till 20. This would have been 20 bits, and then these some 10 bits. So likewise, so anyhow the maximum number of bits that you can have is 30. So this time complexity is nothing but, oh, that's visible, this is nothing but big O of 30. Okay, if let's say 30 would not been given, or a very big number, so we can say that big O of max bits. So between any two numbers, the maximum the bits we have, till those number of bits we need to perform the XOR operation as well as the AND operation. Okay, so for this question, time complexity is equals to big O of 30, which is nothing but big O of 1. Okay, and space complexity is nothing but big O of 1, because we are not taking anything other than a single variable count, okay, and a variable number. That's it. So space complexity is 1. Okay, so that's it for this video, guys. If you have any doubts or anything regarding this question, please write them down in the comment section below. If there's anything that you didn't understood, please mention that in the comments, and I'll see you guys in the next video. Bye bye.